Welcome to the next session of subject engineering maths. Now we discuss chapter 5 probability followed by statistics. In this session we completely focus on basic definitions followed by examples. Now before starting the lecture on probability, let me tell you a few important points you need to follow in the session of probability lecture particularly. Now the importance of probability is you can go to any competitive examination, a banking sector and any competitive examination. So whether it is in the form of aptitude, probability will be covered. Even for gate point of view, probability is the most effective lecture. Even in engineering service also the most effective. So generally when you look at engineering mathematics, we have 7 chapters. So we had already finished linear algebra. So that is generally people can manage linear algebra. Differential equations, if people are expertise in differentiation and integration, they can manage differential equations. When you take calculus, it is almost same as differential equations, part of derivatives and integrations it includes. But even when you take complex variables, most of the concepts what we have used in calculus, all concepts we have used in complex variables like differentiability, continuity, etc. Right? Limits. Now numerical methods, Laplace transforms. So everything almost will be based on derivatives and integrations. So you can manage 6 chapters very easily. But when you look at probability, it is uncertain. More uncertainty will be there in case of probability. But I will make the things very, very clear. I assure you, I make the things very, very clear to you. Please follow the lecture very carefully. You need not be so aggressive. Be very cool. So try to understand each concept. Even I go in a very moderate speed. I won't go even a high-fi speed also. I go in a very moderate speed. So try to understand basics, right? Very, very most effective chapter throughout the engineering maths, probability. Okay. So hope you understand whatever I told you. So try to follow all instructions so that things will be very, very clear, right? Now, let us start with definition of event. Let us see what is an event. Suppose I have conducted an experiment. So sometimes I may get results in the positive way, or sometimes I may get results in the negative way. But whether I get results in the positive way or in the negative way, that is an outcome. Result of an experiment is called an event, or in simple words, any possible outcome of an experiment. Any possible outcome of an experiment is called an event. So what it is? Any possible outcome of an experiment is called an event. Even in the probability, frequently we call the word trial. Trial or experiment or everything is same. So any possible outcome of an experiment is called an event. Suppose when you toss a coin, the possible outcomes are either head or tail. Suppose when you roll a die, see basically die has 6 faces. So the numbers are 1, 2, 3, 4, 5, 6. So basically you won't get numbers. Numbers cannot be appeared. But number of dots will be appeared. On one face you can find single dot. On one face you can have 2 dots. On one face you will have 3 dots like this. So number of faces, number of dots on each face can be either 1 or 2 or 3 or 4 or 5 or 6. So basically all these are outcomes of rolling a die. Therefore all these are called events. So when you toss a coin exactly once, you may get either head or tail. So this is the possible outcome of rolling a coin. So basically what is an event? Any possible outcome of an experiment is called an event. So the best examples are coin and die. In almost in all possible cases, we use coin and die issues. So first one is when a coin is tossed, the possible outcomes are either head or tail. So this is one of the possible event. This is another event. When you roll a die, you may get either phase 1 or phase 2 or 3 or and so on 6. Therefore all these are possible outcomes when you roll a die exactly once. So let us write the definition. Events: any possible outcome of an experiment. Any possible outcome of an experiment is called an event. Any possible outcome of an experiment is called an event. Examples. First one. If a coin is tossed, the possible outcomes are head, tail, H, T. If a coin is tossed, the possible outcomes are H, T. Example 2. If a die is rolled, the possible outcomes are, the possible outcomes are 1, 2, 3, 4, 5 and 6. Next we discuss definition of sample space. Now let us see what is a sample space. So basically sample space is collection of all outcomes of an experiment. Collection of all outcomes of an experiment is called a sample space. Generally sample space is denoted by the alphabet S. So each outcome is an event. So write all possible events of an experiment into a single set S. That will be called as a sample space. Generally we denote sample space with a alphabet S. Let us see an example. Suppose when a coin is tossed exactly once, my sample space S will be like this. S equal to H, T. If a coin is tossed once, so this is my sample space S. When a coin is tossed exactly once, the possible outcomes are either head or tail. Write all possible outcomes of an experiment inside the set S. That will be called as a sample space. So this is my sample space S when a coin is tossed exactly once. Now suppose if a coin is tossed twice or two coins are tossed. So the meaning is same. So you can take a single coin, toss it twice, or you can take two coins, you can toss them parallelly or one after another. You will get 4 sample points. Then my sample space S will be HH, HT, TH, TT. So this is my sample space when a coin is tossed exactly 2 times or 2 coins are tossed one after another or parallelly. So first time you may get head, second time head. You may take single coin. So I toss a coin exactly 1 time. So I got my output is H. Second time I am tossing a coin, assume that my output is H. So therefore every time I have 2 possible chances, either head or tail. So here sequence is very important. First time I may get head, second time I may get head. First time I may get head, second time tail. Or first time tail, second time head, or 2 times tail. So sequences, the sequence of results is very important. Therefore this is my sample space when a coin is tossed twice or 2 coins are tossed. Now the third one is related to die. The sample space S is set of 1, 2, 3, 4, 5, 6. If a die is rolled once. So if I roll a die once, these are my sample points. This can be called as outcome or an event, or you can call it as a sample points. Each outcome inside a sample space S is also called as a sample point. So this HH you can call it as a sample point or outcome or an event. Now my sample space becomes like this: S equal to 1 1 ordered pace, 1 comma 2, 1 3 and so on, comma 1 6 and so on. If I start with 6, so my sample points will be like this: 6 1, 6 2, 6 3 and so on, comma 6 6. If a die is rolled twice or 2 dice are thrown So the meaning is same. If a die is rolled twice, first time you may get outcome 1, second time 1. So let us fix the first outcome as 1. So 1 1, 1 2, 1 3 as well as 1 6. So ordered pair. But each ordered pair contains 2 outcomes. Suppose if I take 1 comma 6, first time I am getting 1, second time I am getting 6. So like this, when you fix the starting outcome as 1, you may get 6 possible outcomes. Similarly, when you start with 2, you may get 6. 2 1, 2 2, 2 3 and so on, 2 6. Starting with 3, again you get 6. So starting with 6, again you will get 36. 6. Therefore, the total number of outcomes inside the sample space when a die is rolled twice or 2 dice are thrown, the number of sample points will be exactly 36. Okay. Now, let us recall the definition of sample space. Collection of all outcomes of an experiment is called a sample space. Generally, it is denoted by the set S. Let us see 4 examples. If a coin is tossed exactly one time, my sample space S will be set of H comma T. If a coin is tossed twice or 2 coins are tossed one after another or parallelly, I will get 4 sample points: HH, HT, TH, TT. If a die is rolled exactly once, my sample space will be like this: 6 sample points. If a die is rolled twice, you take a single die, roll it twice, or you take 2 dice, roll them parallelly or simultaneously or one after another. So the concept is same. You will get 36 sample points. Okay. Now first write the definition of sample space. Collection of all outcomes of an experiment. Collection of all outcomes of an experiment is called a sample space. Collection of all outcomes of an experiment is called a sample space. Collection of all outcomes of an experiment is called a sample space. It is denoted by S. It is denoted by S. Now you write these 4 examples, 1, 2, 3, 4 as it is. Suppose if a coin is tossed n times or n coins are tossed simultaneously or one after another, then the total number of sample points will be 2 power n. So coin is tossed n times. So first time you may get either head or tail, 2 chances. The second time also you may get either head or tail, 2 chances and so on. Even in the last moment n times you may get either head or tail. So this is first time, second time, third outcome and so on n times. So when a coin is tossed n times or n coins are tossed simultaneously or one after another, the total number of sample points will be exactly 2 power n. How it will be 2 power n? If a coin is tossed one time, you may get either head or tail. 2 chances. Even if a coin is the second time, you may get either head or tail. Again, 2 possibilities may occur. So again for third time, 2 chances. For last time, 2 chances. So 2 into 2 into 2. So n times. So therefore the total number of sample points when a coin is tossed n times or n coins are simultaneously is 2 power n. Suppose if the same problem is taken, if you take die, then the total number of sample points will be exactly 6 power n. First time you may get 6 chances, either 1, 2, 3, 4, 5, 6. Even second time also 6 chances. Even when you look at last time, you will get 6 times. So totally this is 6 power n. That means we rolled a die exactly n times or n dice are thrown simultaneously or one after another. So note these points. This number of sample points and this number of sample points are very, very important. Note, If a coin is tossed n times, if a coin is tossed n times, if a coin is tossed n times, or n coins are tossed, if a coin is tossed n times or n coins are tossed, then the total number of outcomes is 2 power n. Then the total number of outcomes is 2 power n. Second point, if a die is rolled once, if a die is rolled once, or n dice are thrown, if a die is rolled n times or n dice are rolled, then the total number of outcomes is 6 power n. Then the total number of outcomes is 6 power n. Now we move to definition of probability. Suppose E is an event of a sample space S. E is an event of a sample space S. I have conducted an experiment, so I got some outcomes. I write all outcomes in the form of a single set S, which I call it as sample space. So E is one of the event of a sample space S. Now I would like to know how many times this event E occurs. So that is measured by probability. Basically, probability is meant for possibility. So the probability of this event is denoted by P of E. And this is given by a ratio, that is n of E divided by n of S. So what do you mean by this n of E? This n of E is nothing but number of times E occurs divided by this n of S depends number of sample points in S. Number of sample points in S. So out of these sample points, how many times the event E occurs? That is nothing but probability of an event. So E is an event of a sample space S. The probability of this event is denoted by P of E, which is given by a mathematical expression n of E divided by n of S. Basically, probability is a ratio. So what is the ratio? N of E divided by n of S. What does this n of E meant for? This is meant for the number of times the event E occurs. How many times the event E occurs? Divided by n of S, out of the total number of sample points. So probability of an event E is defined as the ratio of the number of times E occurs to the total number of sample points in the sample space S. The probability of an event E is defined as the ratio of the number of times E occurs to the total number of points in the sample space. Okay, note this point. Let E be an event of a sample space S. Let E be an event of a sample space S. Let E be an event of a sample space S. Full stop. The probability of E is defined as the ratio of the number of times E occurs, capital E, the number of times E occurs to the total number of points in the sample space S. The probability of E is defined as the ratio of the number of times E occurs to the total number of points in the sample space S. It is denoted by P of E. Therefore, P of E equal to N of E by N of S. P of E equal to N of E by N of S. That is equal to number of times E occurs divided by number of sample points in S. So P of E equal to N of E by N of S, that is equal to number of times E occurs divided by number of sample points in S. Now I will tell you one general example. Suppose if a student appears an examination for 100 marks, assume that a student is appearing an examination having maximum marks 100. Suppose if a student gets the least number of possible marks will be 0. So 0 out of 100. Generally marks has to be represented like this. Suppose if marks are not represented like this. Suppose a student has written examination for 100 marks. Assume that the student has got 72. So if a faculty writes like this 72, it has no meaning generally. It is absolutely wrong. So the student has written an examination for 100 marks. So assume that the student has got 72. If a faculty gives marks like this in the script, so this is not a right representation. They have to write like this 72 out of how many? 100. Because if they write 72, I may do like this. I can write 72 also. So 72 out of 72 means 100%. So therefore you can manage things like this. But so marks has to be represented like this. Okay. Now 72 out of 100. Now you can see the least marks will be 0. If a student writes an examination for 100 marks, least marks will be 0. Maximum marks will be 100. So 100 out of 100. 0 by 100 is 0. 100 by 100 is 1. That means when you take any event E, its probability always lies between 0 and 1. So the probability of an event E always lies between 0 and 1. Sometimes it can be 0 also. It can be 1 also. Okay. So note this point. If E is any event, then 0 less than or equal to P of E less than or equal to 1. If E is any event, then 0 less than or equal to P of E less than or equal to 1. 0 less than or equal to P of E less than or equal to 1. Now we discuss one example of probability related to the problem die. Suppose two dice are thrown simultaneously or one after another. So what is the probability that to get sum? What is the probability that to get sum 8? So this is my problem. So two dice are thrown. So I will get two outcomes. Add both the outcomes. I will get sum. So what is the probability that the sum of the numbers appearing on both dice is 8? Let us see. When you take two dice, the total number of sample points will be 36. 6 square 36. So sum must be 18. That means the possible number of cases is like this: 2, 6. This is first outcome. This is second outcome. 2 plus 6 is 8. Or first time 6, second time 2. Or first time 5, second time 3. Or 3, 5. Or you may get 4, 4. So these are my favorable cases. So add these two, you will get 8. Here also 8, 8, 8, 8. So how many sample points are there? 5 sample points. 5 out of 36. Therefore, the required probability is 5 divided by 36. 5 chances out of 36 sample points. Got it? So write the example as a general problem. What is the probability? You write it as a question. What is the probability to get a sum of 8? What is the probability to get a sum of 8 when two dice are thrown? What is the probability to get a sum of 8 when two dice are thrown? So the answer is, the probability P is 5 by 36. So 5 chances are like this. You write these 5 chances. 2, 6, 6, 2, 5, 3, 3, 5, 4, 4. In all the 5 occasions, you will get some value 8. 5 out of 36. Now we discuss one more point. Suppose if E is any event and E bar or E power C. So basically they will be called as complement of E. Complement of E. Suppose if E is an event of getting an even number, then E complement is nothing but an event of not getting even number. Negation. Negation means negative direction. So if E is an event and E bar or E power C is complement of this, then the equation connecting P of E and P of E bar, this will be always 1. So P of E plus P of E bar will be always 1. E is an event. E bar or E power C. Basically, this is nothing but complement of this event. If E is an event of getting even number, then E power C is an event of not getting even number. Not getting. So in that case, P of E plus P of E bar will be always 1. So you take any event E and look at its complement, then P of E plus P of E bar will be always 1. Not if E bar is complement of E, if E bar is complement of E, then P of E plus P of E bar equal to 1. If E bar is complement of E, then P of E plus P of E bar equal to 1. Next concept, addition theorem on probability. Suppose E1 comma E2 are two events. E1 comma E2 are two events. Basically, these two events need not belong to same sample space. This may belong to one sample space, this may belong to another sample space. So I can take two events related to two different experiments also, or I can take two events belonging to same experiment. So that is different issue. So we have two events E1 and E2. Then I can find P of E1 union E2. So generally union is meant for OR. So what do you mean by P of E1 union E2? This is the probability of occurrence of either E1 or E2. Probability of occurrence of either E1 or E2. And this expression is given by P of E1 plus P of E2 minus P of E1 intersection E2. P of E1 plus P of E2 minus P of E1 intersection E2. This P of E1 intersection E2 is nothing but probability of occurrence of E1 and E2. Generally, intersection is meant for AND. Union is meant for OR. So therefore, P of E1 union E2 is nothing but probability of occurrence of either E1 or E2. So you may get event E1 or E2. This is given by P of E1 plus P of E2 minus P of E1 intersection E2. The last expression gives probability of occurrence of E1 and E2. Actually, this resembles the statement like this. Suppose when you take sets, A and B are two sets. A and B are two sets. N of A union B. This is nothing but N of A plus N of B minus N of A intersection B. Actually, this N represents the number of elements in the union of two sets. A is one set, B is one set. So here N of A union B represents the number of elements in the union of two sets A and B, which is number of elements in A plus number of elements in B minus number of elements in A intersection B. Because if an element repeats in both the sets, that has to be counted only once. If a particular element repeats in the set A as well as B, we were counting that element here. I am counting that element here. That means unnecessarily I am counting a single element twice. Therefore, you subtract. So I am counting it twice, subtract one time. So that means finally I am counting that element exactly one time. Each element has to be counted exactly once. Therefore, here also the same. If I apply this for three events, then my result will be like this. P of E1 union, E2 union, E3. This is given by Here we have three events. So at any time you consider one event. After that two events. After that consider all three events. Then this expression becomes P of E1 plus P of E2 plus P of E3. Now you consider two events at a time. So minus P of E1 intersection E2 minus P of E1 intersection E3 minus P of E2 intersection E3 plus P of E1 intersection E2 intersection E3. Let us see the magic with this. Here we started with the three events. You consider only one event at a time. So P of E1 plus P of E2 plus P of E3. Positive signs. Next you consider two events. E1 and E2. E1 and E3. E2 and E3. Next all events. Now you can understand. Sometimes sometimes there is some gaining. Sometimes we are losing some probabilities. So suppose if if a sample point repeats in E1 and E2 and E3. If a sample point repeats in E1, E2 and E3. So that means we were counting at this place, at this place, at this place. So therefore that has to be removed at this place, at this place, at this place. So three times we were counting, three times we were subtracting, but that will be gained again in the probability of E1 intersection, E2 intersection, E3. Are you following this? If an event repeats in all the events, even E2, E3, if a sample point repeats in all events, E1, E2, E3, so we were counting the same event thrice, but it has to be counted exactly one time, but unnecessarily we were counting three times. Therefore, subtract this three times, add three times, subtract three times, so it will be nullified, but it has to be counted one time. So plus P of E1 intersection, E2 intersection, E3. So therefore, this is addition theorem on probability for three events. Addition theorem on probability for two events. Okay. So write this as 0.1 and this as 0.2. So here you write the point where P of E1 union E2, where P of E1 union E2 is the probability of occurrence of E1 or E2. P of E1 union E2 is the probability of occurrence of E1 or E2. P of E1 intersection E2. P of E1 intersection E2 is the probability of occurrence of E1 and E2. P of E1 intersection E2 is the probability of occurrence of E1 and E2. And so this is about addition theorem on probability. Next definition or concept, conditional probability. Conditional probability. Now here in the title itself you can easily guess the probability depends on certain condition. Probability depends on certain condition. Suppose we have two events E1 comma E2. Assume that E2 is already occurred. E2 is already occurred. It is already happened. So based on this condition, what is the probability of getting E1? What is the probability to get the event E1? That we denote it as mathematically like this, P of E1 slash E2. So this is the probability of occurrence of E1 when E2 is already occurred. So this is called probability of E1. Probability of E1 given E2. Given E2 means E2 is already occurred. So probability of occurrence of E1 when E2 is already occurred is called probability of E1 given E2. Symbolically we write like this, and this is measured by simple expression. It is P of E1 intersection E2 divided by P of E2. So this is conditional probability. we have two events, E1 and E2. E2 is already occurred. So in that occasion, in that situation, what is the probability to get event E1? That we denote it as P of E1 slash E2. Probability of occurrence of E1 when E2 is already occurred. One event is already occurred. So whenever an event is occurred, you write the right hand side. So E2, P of E1 slash E2. Probability of occurrence of E1 when E2 is already occurred. That we call it as a probability of E1 given E2. So this is given by P of intersection of these two divided by P of this. P of this. Write this point. The probability of occurrence of E1. The probability of occurrence of E1 when E2 is already occurred. The probability of occurrence of E1 when E2 is already occurred. The probability of occurrence of E1 when E2 is already occurred is called probability of E1 given E2. Is called probability of E1 given E2. First off, it is denoted by P of E1 slash E2. It is denoted by P of E1 slash E2. Therefore, P of E1 slash E2 equal to P of E1 intersection E2 divided by P of E2. P of E1 slash E2 equal to P of E1 intersection E2 divided by P of E2. As definition, independent events. Very, very important. Independent events. Suppose we have two events, E1 comma E2. Two events, E1 comma E2. We say that these two are independent if the occurrence of E1 does not affect occurrence of E2 and vice versa. I write it very clearly. We say that these are independent if the occurrence of E1 does not affect E2, and vice versa. Vice versa means reverse. So if the occurrence of E1 does not affect occurrence of E2 and vice versa, in that case both the events are called independent events. That means sometimes I may say that the probability of getting pass in one subject is 70%. If I want to pass in one subject, the probability is 70%. What does it mean is, if I appear an examination for 100 times, there is a chance to pass in that subject only 70 times. That means what is the probability of getting failed in that subject? Remaining 30 cases. So therefore both are dependent events. So probability of failure always depends on probability of success generally. So in that case, probability of getting pass in one subject depend on probability of getting failure in the same subject. So therefore they are called dependent events. But in this case I am saying that independent events. So if the occurrence of E1 does not affect occurrence of E2 and vice versa, then they are called independent events. I will tell you one example. Suppose E1 is an event of getting ahead and E2 is an event of getting an even number. So see, whenever I say that head, this is related to coin. So let E1 be an event of getting a head when a coin is tossed, and E2 be an event of getting an even number when a die is rolled. When a die is rolled. Now I have selected two different events over two different sample spaces. In that case, its occurrence does not affect this. So if I want to get head, it doesn't depend on getting whether it is an even number when a die is rolled or not. So this event and this event both are independent events. So its occurrence does not affect its occurrence, and its occurrence does not affect occurrence of even. Now in this case, I would like to find P of even intersection E2, and this is given by P of even dot P of E2. So therefore, when you have independent events, the probability of occurrence of E1 and E2 is given by P of E1 dot P of E2. That means this intersection becomes dot. So I don't want to continue for probability of E1 and probability of E2, but this result is very useful for us in solving many GATE or IES questions. So E1 is an event of getting even number, I mean head, when a coin is tossed. E2 is an event of getting an even number when a die is rolled. So in that case, they are independent events, and in that case, P of E1 intersection E2 becomes like this. Intersection becomes dot. So write the definitions. Two events, E1 comma E2, are said to be independent. Two events, E1 comma E2, are said to be independent if the occurrence of E1, does not affect occurrence of E2, if the occurrence of E1 does not affect occurrence of E2, and vice versa, So you can take these two examples. I will discuss this point in the next session also, but for the time being, you try to write these two examples. E1 is an event of getting a head when a coin is tossed. E2 is an event of getting an even number when a die is rolled. So in that case, both are independent events, because intentionally I have selected two events over two different sample spaces. 100% they will be independent to each other.